Welcome back to my favorite people. And as usual, thank you very much for watching this lecture video. I'm going to go through oxidation number of carbon. The reason for it, we can use oxidation reduction to technically make some alcohol or to turn it to another compound. And how do we calculate oxidation number of carbon? So as you see here, the oxidation from -4 is turning to +4. And so let's write these two terms. We have LEO stand for loss of electron. Loss of electron is oxidation. That means the positive charge is gonna go up or it will increase. So loss of electron is oxidation, and gain of electron. So I go gain of electron is reduction. That means positive charge will go down and it will turn to more negative. And so as you see, if we move to the right side, the oxidation number is getting more positive. That means we are losing electron, and from -4 to 2, we lost 2 electrons. And then here again -2 electrons. And if you go back from, for example, 4 to +2, in this case, we gave carbon 2 electrons, so carbon gained 2 electrons, and that one I'm going to call it reduction. So the reverse one, it will be reduction. Well, the forward one, it will be oxidation. So if we go to the right side, because we are increasing the positive charge, it will be oxidation. If we go back, it will be reduction. Okay, how do we calculate the oxidation number of carbon? Say you have this compound, carbon attached to 4 hydrogen. Electronegativity of carbon higher than hydrogen, so you can simply say I have a carbon plus 4 hydrogen, and the compound is CH4, has no charge. Okay, so I'm going to say the common charge for hydrogen is going to be +1 versus carbon. And so we say we have 1 carbon plus 4 hydrogen equal to 0. I'm looking for carbon, so I say carbon plus 4 hydrogen multiply +1 for each hydrogen equal to 0. We say carbon plus 4 equal to 0. So let's add 4 to both sides. Subtract 4 from both sides. If we subtract 4 from both sides, we get oxidation number of carbon equal to -4. Another one, let's say we have carbon attached to 2 hydrogens and oxygen. Okay, the common charge for hydrogen, it will be +1. We have 2 of them. And the common charge for oxygen is -2. So I have -2 for oxygen, and 2 hydrogen, they are +1. So the negative charge is -2 and the positive charge is +2. So carbon must be 0. Okay, let's check it. We have carbon plus 2 hydrogen plus 1 oxygen equal to the charge, and the charge is 0. I go carbon plus 2 multiply +1 for hydrogen, and then 1 multiply -2 for oxygen, and that's going to be equal to 0. So I get carbon equal to 0, and here you go, oxidation number of carbon equal to 0. Another one, how do we assign oxidation number of this compound? So let's replace one of the hydrogen in methane by OH. And I know that the common charge for oxygen is -1, and for hydrogen is a +1. Okay, now what's going to be the common charge for OH? If this one is -1 and hydrogen +1, that's going to be -1. And we know OH, it has -1 charge. So I have a carbon plus 3 hydrogens, okay, 3 hydrogen plus 1 OH, okay? This hydrogen, the one I'm highlighting, is attached to oxygen, not carbon, okay, attached to hydrogen. So we need to keep this one away. And so that's going to be equal to the charge, which is 0. Carbon plus 3 hydrogen is a +1. And then we have 1 OH is -1. That's going to be equal to 0. So it's a carbon plus 2 equal to 0. You subtract 2 from both sides. And that's going to give us oxidation number of carbon equal to -2. And let's prove it again. This one is a +1, +1, and +1. Okay, we have a +3 here. This one is -1. Okay, if in order to keep it neutral, or in order to keep it neutral, because we have +2 until now, we have 3 plus and 1 minus. That's going to be +2. So the carbon must be +2. Okay, oxidation number of carbon must be +2. And yes, forgive me, -2, not +2, -2, because we have excess of positive charge. Okay, now we said carbon is capable of having different oxidation number, as you see, -4, -0, or -2. So oxidation number of carbon keep changing, and it means we can actually oxidize or reduce carbon. And in order to oxidize, alcohol and turn it to something else, we need to have OH attached to a carbon that at least has one hydrogen attached to it, at least one hydrogen attached to the alpha carbon. And so we're going to subtract H2 from it, technically hydrogen gas from it, and we will turn it to carbonyl group. Or you can take the carbonyl group and just simply reduce it. And how do I reduce it? I'm going to add hydrogen gas to it. And if I add the hydrogen gas to it, it will turn to alcohol. And so I'm going to write this. If we take an aldehyde, say we have this one, aldehyde, this is going to be aldehyde, and we reduce the aldehyde. If you reduce it, run reduction, that's going to give us a carbon that's attached to, say, R, and then of course we have hydrogen here, and we will get OH. Then there will be a hydrogen here. That means this alcohol is going to be a primary alcohol. Okay, if we reduce aldehyde, but if you reduce a ketone, and say you have R, attached to carbon, and there is another R. Okay, another R. They can be identical or not. And again, we go through reduction. So if we reduce the carbonyl group, I'm talking about this functional group, and in this case, we get R attached to carbon, attached to another R. Now we will have OH here, and and here we have hydrogen. That's going to give us a secondary alcohol, because our carbon is a secondary carbon. So OH, it will be, and then like the alcohol, it will be a secondary alcohol. Reduction of aldehyde, and aldehyde will give us a primary alcohol. Reduction of ketones always will give us a secondary alcohol. Okay, now in this case, I have an aldehyde. How do I know I have aldehyde? Aldehyde, okay, you will see a carbonyl group, a carbonyl group. This is the carbonyl group that has H on one side. That means you are dealing with a primary carbon. Okay, primary carbon. Reduction of primary carbon or reduction of a carbonyl that it has H attached to it, or is a primary, carbon, is going to give you primary alcohol. Okay, so this is a primary carbon. That means the alcohol, it will be primary. And when you use hydrogen gas exposed to a catalyst, like, and say palladium, nickel, as a catalyst, or other elements, there will be no selection. Anywhere you have a double bond, that double bond will be simply reduced. The first example, I have only one double bond, so I'm going to use only 1 mole from hydrogen gas. So I go 1 mole from H2 gas. But if you have more than Okay, more than one double bond. In this case, I have a carbonyl group and two also double bonds there. So degree of unsaturation, it will be equal to 3. And because it's equal to 3, I need to have 3 moles from hydrogen gas to saturate this compound. So I will get technically 2 hydrogens here, 2 there. Okay, 2 moles until now. And now I get OH here and also 1 hydrogen there. Again, this is gonna be a primary alcohol because our carbon is a primary carbon. Now, if you have a ketone, okay, instead of aldehyde, so this time we have ketone. Reduction of ketone will give you alcohol, but the alcohol, it will be a secondary alcohol because carbon is attached to 2 carbons, and so it's going to be a secondary alcohol. Okay. Now, I do have we do have other reagents that they can actually reduce carbonyl groups, and whether they are aldehyde or ketone, they can easily reduce them. One of them is sodium borohydrate, and then the presence of methanol, and or any technically in solvent that has acidic H. And this one is going to give us such a product. We will get first step BH4. It will give technically H to the carbonyl group. So H minus, it will attack the carbon, and we will have H here. That's going to give oxygen with 3 lone pair oxygen. It has a negative charge. Very soon, oxygen is going to look for acidic H, and it can find it inside methanol. Okay, this one, it has partial positive charges. So solvent, it will go after that H, and it will turn to such a product. Okay. So the carbon group turned to alcohol because it's a ketone. Again, we get a secondary alcohol. In this case, addition, it can happen from the top or the bottom of the molecule. So technically, I'm going to get this product. So I'm going to say OH, it can be facing to us. I'm going to write OH here. Or OH might be back of the molecule. So plus, raise this part and write it dash and say OH. These two are enantiomers. Okay, now there is another reagent, and that's going to be lithium aluminum hydride. It will do exactly same job as sodium borohydrate, and wherever you have carbonyl group, it will saturate it and it will turn it to alcohol. And in this case, I have 1, 2, 3, 4, 5, 6, 7 carbons. So I go 2, 3, 4, 5, 6, 7 carbons, and first carbon we're gonna have OH. And also we do have H there. Okay, so this is gonna be a primary alcohol because we started with aldehyde. Again, this is 1, 2, 3, 4, 5, 6, 7 carbon. So I got primary alcohol. And because we have a primary alcohol, and that means we have 2 hydrogens technically there. We're not going to have stereocenter on that carbon. Okay, I'm going to stop the lecture here, and thank you very much.